Hello, everyone, and welcome to Business 640. I would love to talk about chapters 3, 4, and 5 today. And as we start with chapter 3 really begins with product design, and product design is a crucial part of any business, especially when it comes to trying to meet the physical demands of their products to meet their customer needs, desires, and wants, and it really is part of their overall strategy, their business strategy. And if we see over on page 43, we see where Ford Motor Company, the operations leader segment, spends a tremendous amount of money when it comes to research and development. And research and development is a key piece of any company's business strategy as they go about trying to meet the needs again of their customers. And as we talk about strategies for new product introduction, we see market pull, technology push, and interfunctional view. And you see this very cute or very humorous figure on 3.1, the differences between the marketing and what the customer really wanted, and how crucial that cross-functional decision making and communication plays into any businesses today. And as we think about the strategies for new product development, when you're looking at market pull, it's really about what the customers need, how they've been determined, how they have been communicated, and how they have been understood, and then how the firm organizes the resources and the process needed to ensure that the product will pull through the manufacturing process so that the customer can get exactly what they need. And the technological push is the primary determinant of how the product the firm should make. And in some cases, they're not doing very good market research, and they're all just doing technology, and they're being literally pushed into the market. And then it becomes the marketing job to create demand for these products. It's almost like build it and we will come, or the customers will come, which is certainly a strategy, but it may not be the best strategy. And then the interfunctional view is the view that the market needs have been determined, and they'll have a technical advantage as well. And that should include the marketing, engineering, operations, and finance. That's become that cross-functional team, that cross-functional decision making that is so vitally important in today's businesses. And then when we talk about there's a few phases when it comes to this new product development process over on page 44 and 45. And they typically follow a phase of when firms develop new products. They have the concept development, product design, then their product pilot, production, and testing. And each one of these phases is concerned with a new idea generation and evaluation of other alternate ideas for any particular new product. So again, you have the concept development phase of it. Then we have the product design, where we're looking at this phase is concerned with designing the physical attributes of that new product. And again, it begins with that consideration of trade-offs between product cost, the features, what the customer's demands and needs, the type of manufacturing that they may have, and the schedule that's going to be needed to do that. And certainly we know that standardization is a key part to any manufacturing process. And the more it can standardize without having to change its manufacturing processes or equipment, the cheaper per unit cost it can produce. And when customers' demand changes and we get into customization of specific products, then the per unit cost certainly will increase. Then we talk about the third phase in the production prototypes, where they're actually developed and tested before they're actually taken to market, similar to a pilot program or a pilot survey. They test them out and make sure that they're going to work correctly and that it's going to meet the customer's demands and needs. And you see that figure 3.2, it kind of gives you a visual representation of that process. Excuse me. Then over on page 47, we talk about cross-functional product design. And when you're looking at cross-functional product design, there's this thing called misalignment. And no matter how efficient the advanced planning may be, misalignment between product design and operations certainly will occur. And it certainly can occur in miscommunications, misunderstanding, and not fully grasping what the market demands are, or poor marketing concepts, because marketing really is about seeing what the next market is, then communicating that throughout the organization so that the engineers, in the example, can redesign its products so that the customers can get exactly what they need. And I keep saying what customers need because we are a customer service oriented business environment today, more so than in recent years. And it's really about satisfying what the customer wants and what the customer needs. So this cross-functional product design talks about misalignment. And this is a sequential process, and you see that down in figure 3.3, where as the new product development approaches, where throughout all these organizational functions, and we have marketing, engineering, and operations as an example. All of this is involved throughout this concurrent process. So this concurrent engineering process really is taking all those different functions, merging them together so that they're communicating across divisions and functions so that, again, we can ensure that the customer gets what they need at the least cost possible. Over on page 48, we talk about supply chain collaboration. And collaboration means just that, where we're collaborating with the customers, tapping into their knowledge and experience to see what they're willing to buy. And that's part of that marketing research, when we're out there asking the customers the right questions. And then we are aligning our technological platform to meet their customer needs, and maybe even offering some type of customer incentives to get them to come and buy their goods and services from us. Then over on page number 50, we go into the quality function deployment. The quality function deployment, QFD, is a tool by which we link what the customer's requirements are or their technical specifications. When we take those technical specifications and we translate that into ordinary language that the customers can understand, but we convert that to technical requirements that's understood by our engineers, but also understood by our marketing, manufacturing, our manufacturing capabilities as well. And this QFD identifies what are the customer attributes, and you see that over in figure 3.4 on page 51, where we have the customer attributes on the left side of this matrix, which can be related to the engineering characteristics, which is at the top of the matrix. And then over the right-hand side, we have what are the customer perceptions related to what we thought we understood, what engineering, from engineering perspective, compared to what the customers wanted, and that are we providing that to the customer. And in this particular matrix, it was popularized by Hauser and Clausen, and it is known as the house of quality. And you talk about, in this text at least, in this particular model, talking about a bicycle, but this particular concept can be used with almost any type of process or product that a customer would want. And then we talk about customer attributes again, which is shown on the left-hand side of the matrix. But this really represents what the customer wants. So where did this information come from? Doing that collaboration with the customer. Doing your market research and your market analysis is very important to do that. And once these customer attributes have been listed on the left-hand side, they're typically rated on the relative importance to the customer. Like easy to pedal is 10%, all the way down to etc. or any other type of customization down to 25%. But the sum of it's got the total 100 points. And this is really shown in these particular columns are called chimney columns. And you see that at the bottom of page 51. So these columns are called chimneys, but that attributes the relative importance to the customer has got to sum up to 100%, which makes perfect sense. Then we look over on page 52 where we go into some of the engineering characteristics related to what this customer is looking for. And if I may back up just for a moment. When you look at this house of quality, the difference between figure 5.3 and 5.4, figure 3.4 to figure 3.5, you see that the matrix has kind of changed a little bit. Now we've added what appears has all the looks of a roof, that triangle type roof on top of it, which is additional attributes that were added that are checked off by the customer as well as the organization that's developing this particular product. So these kind of trade-offs at the roof to the house of quality. This roof shows how the engineering characteristics is related to other engineering characteristics. And it makes it possible to study the trade-offs between each as we go about trying to meet the customer needs. And at the bottom of the matrix in 3.5, we look at the value of each engineering characteristic as it's achieved by the competitors' bicycles as well. So not only are we analyzing ours, but we're analyzing ours against competitors as well. So we have the importance of various customer attributes that's being displayed in these particular house of quality matrix in 3.4, 3.5, 3.6. We also have the linkages to the engineering characteristics associated with that. And we're looking at the performance of the product as it's related to its competitors or our competitors. So that's kind of how we can use these house of qualities and the importance of that when it comes to customer attributes and how we go about rating those customer attributes internally as well as externally when we look at compare ourselves to our competitors. Excuse me. Then over on page 54, we look at value analysis. And that value analysis really is a method to which we use to look at a product to see how useful it is and what can we do to increase or reduce its cost without reducing its usefulness to our customers. So it's really considering if we were to make a change to the product, whatever that change may be, it could be a change in the color or the size of as an example, a pencil eraser. It could be the difference between a lid, say, a cup at Burger King. If I go to Burger King or if I go down to my local fast food restaurant and I order a soft drink, and I look at the only difference in the size of the cup may be or difference in the cups may be the number of ounces that they will take. But if I can use the same standard lid, instead of having multiple or different sizes of lids, and if I could redesign my cups so that one lid fits all cups per se, even though each cup will hold more value, but the lid itself has the same circumference. If I can do that, then I'm looking at this design for manufacturing. I'm doing a value analysis to try to determine, can I, in this example, still meet a customer need while providing a standard product, which is going to lower my overall manufacturing costs. And you see that kind of said that there in in section 3.6 over on page 54. And they give us a figure 3.7, which uses a different type of analogy about what's the best way to open this can. And we also have figure 3.8 when we're looking at a toolbox using design for manufacturing, how we can go about manufacturing a toolbox from 20 to 2 parts. So it's all about, again, maintaining a value analysis that the customer still finds useful, still meets the need for the customer, but as a way in which we, as a manufacturer, can go about doing manufacturing in a way that still provides a useful product, but at a much lower per unit cost. And as customers, we're certainly sensitive to cost. Then over on page 56, we go into modular design, which is an extension of this particular discussion when we're looking at trying to control the number of different components that may go into building something that a customer needs. And we have over on page 57 that Dell computer as an example, trying to look at the different combinations of how many products or components are needed to make a laptop computer function. And this modular design is all about trying to have high product variety while ensuring that the customer needs are being met. But again, can I make it at a much lower per unit cost? And that's really what chapter 3 goes into discussion about. So let's go over to chapter 4. Chapter 4 goes into the second phase of this process design, which the first phase in chapter 3 dealt with the product design in chapter 3. Chapter 4 deals also part of process selection. And process selection decisions are strategic in nature. They require long-term perspective and a great deal of cross-coordination, since marketing, finance, human resources, and operations, which we saw back in chapter 2, are all affected from these type of cross decisions and cross functions that's going to be needed, so that the processes that are being selected is going to ensure, again, customer needs are being met, but yet our per unit cost is at the least cost possible, because, again, customers are price point conscious. So let's look on page 63 where we talk about product flow characteristics. We have a few different characteristics here. There are 5 types of product flow that is mentioned: continuous process, assembly line, batch, job shop, and project. And depending on the type of manufacturing process that you're using will determine which one of these product flows that you may use in a manufacturing process. So the continuous process is just that. It is a process that industries are using, especially when we're talking about commodity products such as sugar, paper, oil, electricity per se, that they are continuously being manufactured. That those particular commodities typically are operated at capacity, where they minimize their inventory and distribution costs, which reduces their overall total cost. They have high volume of use. So therefore, they're constantly being used. They're not being used on any certain percentage, but they're constantly being manufactured per se. Then we have this thing called assembly lines. Assembly lines is also characterized by a linear sequence of operations. Assembly lines operations are very efficient because once I get through this step, it goes to the next step, goes to the next step down the manufacturing process. If you think about the automobile industry, that's kind of what it makes me think of when I think about a linear sequence of operations. Very efficient, but yet inflexible because the line runs at a constant speed. And because of that constant speed, the volume can be altered by changing the number of hours that's being worked. And as you can imagine, that anytime you retool in an assembly line, the assembly line is going to be shut down. So that's where the inefficient piece comes into play. And you see figure 4.1 kind of gives you a graphical example of an assembly line in this particular discussion. Then we have a batch flow, which is characterized by production in batches or lots. And you see that over in figure 4.2 at the bottom of page 65. And batch operations are used for general purpose equipment where it's not a very specialized type of process per se. And if you think about a batch process, think about it from this particular standpoint. It really is about how one operational work affects another, or how in this particular example, a work center is a group of similar machines or processes to make the particular product. And if I take that to the world of academia, and if I think about that from the standpoint of how students come into the MBA program and how all the different courses that they're going to be taking as they kind of flow through or work their way through from beginning to the end is kind of an example of this batch flow process per se. Then we have over on page 66, we have this concept of jumble flow, which is looking at the production scheduling and inventory challenges, as well as the process layout, how the process and the product are laid out in order to maximize the efficiency of how the product is batched together, how the workflow is working. As an example, if I have multiple machines that's required to produce a product, if I can lay out that process where it takes minimal steps by employees who operate in the machines to go back and forth towards the machine would be an example of that. Then we have this concept of job shop, where products are made to order to the customer. And you can imagine this would be somewhat expensive. And in a job shop, the product is made in batches, usually in small lots, but they're made to a customer order, and they're really this is where customization comes into play, and standardization does not. And you can imagine just by saying those two terms, the amount of cost that potentially would incur. Then we have this thing called project, which is the form of operations for when you're looking at something unique or creative. Examples are concerts, construction of buildings, production of large aircraft, as an example. So those type of different types of product flows are just a few examples that were discussed in our textbook, and give you a few examples. And you kind of see that table 4.1 at the bottom of page 61, kind of giving us the process characteristics of those different type of product flows. Then let's talk about on page 67, process types, throughput ratio. And this is interesting concept is a way to measure efficiency of a process. And we know that in business, we're all the time wanting to improve our processes. We want to measure our efficiencies, our outputs. Key performance indicators will probably be another term you're accustomed to seeing, but it's a way of how do I take how efficient measurement I am in my particular manufacturing process in this particular one. In this particular example, we're looking at least one way to measure the efficiency of a process is the throughput ratio, TR, which you see that on page number 67, which is the total processing time for the job and the total time in operations. And as you think about that, most batch job operations have TRs or throughput of 10 to 20%. And that's because, again, batch and job shop operations are the most inefficient. And this is where batches and job shop operations, you would typically have a lot of customization, where we know through continuous processing and assembly lines that throughput ratio would be much, much, much higher than 10 and 20%. Because if it was not, then that kind of negates the reason why we even have continuous processes as well as assembly lines when it comes to manufacturing processes. But this total processing time for the job divided by the total time in operations. And there is a processing time, and when you think about this particular formula, don't lose track of that the total time in operations also includes the total processing time in that numerator as well. As an example, let's say that I have a product that it takes 10 minutes to manufacture, to actually do the manufacturing process, but it takes me another 30 minutes to which for that process to flow through the batch flow manufacturing. So the total time in operations would be 40 minutes divided by 10 minutes. If we, in this example, if we were using it in minutes, could be in hours, could be in days, but in this example, let's use minutes. So don't lose sight of the fact of that total time in operations includes the total processing time plus that total time through that manufacturing process from start to beginning. Let's say that it's 60 minutes to make a widget, but 10 minutes or 40 minutes to make that widget, where 10 minutes is actually the assemble process, where 20 minutes coming to it to get it ready to assemble. Then let's say the next 20 minutes may be the packaging, things of that nature, getting it ready for shipment. But anyway, I think you get the concept of what I'm trying to say. So don't lose track of that. Now let's look over on page 68 and 69 as we go into the approaches to order fulfillment. We have a made to stock process, which provides faster services to the customers, which is delivering orders available from stock. We have the made to order processes, which provides a little bit more flexibility, maybe a little more expensive. And as we look at this made to order processes, after the order has been received, the design must be completed. If it's not already done, then the materials will have to be ordered if they're not already on hand. Once the materials have arrived, you begin the manufacturing process. Once the manufacturing process is completed, then the order can be processed. Then once the order is processed, that order can be delivered to the customer. And once the customer pays for that order, then the cycle is completed. And the key performance measures for a made-to-order process are the length of time it takes to design, make, and deliver that product, which is typically referred to lead time. And you see that over on page number 69 when it comes to lead time. So made to stock, made to order good concepts as you study pages 68 and 69. Then let's talk about if a product is not available, it's not available in inventory, then we have this concept which is called back order, which a back order may be placed or the order can be lost to another firm. So as customers, the thing that we don't want to do is to wait. Now, Amazon certainly has changed that concept, because if you buy anything from Amazon, that you know that you will wait. But if you're a Prime customer, some of the other things that they kind of help bridge that gap. But it's not like walking into your local store, putting your hands on it, taking it to the register, and walking out with it. And if you think about how potentially devastating that could be to an organization, that the majority of times I go to their business or go to their website to order something, and I cannot get it in a reasonable amount of time because it's on back order. One way to overcome this is looking at the service level, also at the page, at the bottom of page 69, which is looking at how I can ensure or predict based on usage, service level based on usage, as an example, how I can overcome that back order. Then we have the assembly to order process, which is a hybrid of the MTO and MTS process that we see over on page number 70. And they give us figure 4.3 as you study that to see the differences between the two. Then they give us table 4.2, made to stock versus made to order concept, as again, another example of the differences between the two. And if you think about one of the, at the bottom of page 71, Subway and the operations leader uses an assembly to order. They don't have their sandwiches setting up on the shelf. They have all the components and they customize it to what you want. So they assemble to order is the process to which that they use. And have it almost like Burger King, have it your way. Assembly to order process. Now look over on page number 72. We'll be looking at the customer order, the MTS, MTO, or ATO, which determines the order penetration point in that supply chain where the product is linked to a specific customer order. So for the MTO, many types of customizations are possible, but the lead time to the customer can be longer if the product, and especially if you go into customization, and typically will cost more money to you as well. So that penetration point, order penetration point, sometimes called the order decoupling point, that we see there in page, again on page number 72. Look over on page 73 with me, if you would, when we're looking at the made to stock, made to order, assembly to order, and the process characteristics of the differences between the three. Now, when we talk about this product process selection decisions, there's usually a couple of components that comes in to that. The first is being the company should consider the market conditions, because you know if you're not doing mass marketing and understanding what your customers needs, then you may be making products that simply cannot sell. Then the second thing the company should consider in this process selection decision is the capital requirements. If you're thinking about an assembly line and the cost that it takes to build an assembly line and the cost of labor to man it, is very, very, very capital intensive, which it goes into the third factor, which should be considered the availability of labor and the cost of that labor, especially with project and batch processes, which are typically high in labor costs. But an assembly line, I mean, it is continuous assembly line. A continuous process and a assembly line, by their very nature, are designed to minimize hands-on. The reason why it is a assembly process, so to speak. I'll get my words straight here in a moment. And finally, the other thing that the company should consider is the cost and utilization of technology. And you kind of see this, those four factors appear in table 4.3 again, as well as over at top of page 74, where they talk about market conditions, capital requirements, labor, and technology. Now let's look at product process strategy, where they give us this figure 4.5, and as a product ranges from a unique, one-of-a-kind to a high-volume, high-standardization commodity, which if you're reading this particular matrix, it typically reads from left to right, top to bottom. If we think about it from this standpoint, that a unique, one-of-a-kind product is not going to be in a continuous type of production process, but neither is a project going to be a high volume, high standardization commodity as well. But as you look at this particular structures, as we go from a building down to sugary refinery, a building could be a project, unique, one of a kind, all the way down where sugary refinery commodity is going to be a continuous process, which is going to be high volume, high standardization commodity. So that's the different as you look at that particular figure. And it kind of takes on this process has a life cycle, which is very similar to a product life cycle that evolves from a unique project type or production at the top of the matrix to a continuous process there at the bottom. So it kind of takes on that semblance of a life cycle. So this is the product process matrix, and figure 4.5 to 8 help us as we're trying to determine the unique, one-of-a-kind all the way to a high standardization commodity. Then we have focused operations over on page number 76. We look at the focus factory as it talks about a plant within a plant. And Honeywell is a good example that they're using here, the concept of the focus operations by a plant within a plant concept. Then we have mass customization, very interesting section on page number 77, where we have mass customization, which is a strategy that provides products and lot sizes of high volume. And then we have this concept called traditional mass production, which is built on economies of scales by means of high volume standardized product with very few options. If you have ever heard the term that Henry Ford coined, that you can have any color that you want, like in the Ford manufacturing that when it early got started, you can have any color you want as long as you get black, because it truly was about mass production. Standardization was his key when he first started the assembly line process making the Ford Model Ts. So that's an example of a traditional mass product, which is built on economies of scales with high volume standardization with few options. And we know with economies of scales, the more production, the use of economy scales equates to more production gives a per unit lower cost. Now, in contrast to the traditional mass production, we have this concept of mass customization, which depends on economies of scope. And this mass customization has a high variety of products from a single process. And if you can imagine that economies of scope can also reduce the average unit cost due to production of several products by using the same process. And mass customizations comes from a different economic basis, a common process rather than a common product. So both of these particular concepts can be utilized. Both of them have their needs. but yet if you want mass production, you typically go with economies of scale. If you want mass customization, you typically go with economies of scope. So if you can use economy of scope to produce multiple products using the same process, you can certainly reduce your per unit cost. However, if you cannot do that, then your per unit cost may be even higher. Then I think over on page number 78, where we're looking at the order entry process, which is streamlined from mass customization, 3 forms of mass customization: the modular production and assembly to order, the fast changeover, which has 0 setup time between orders, then the postponement of options, and it gives you a little bit more examples and details on that particular page. Well worth your reading. Environmental concerns, we're certainly in a more environmental societal norms today than what we have seen in companies that do have a environmental contract that they got to upheld as they're doing their manufacturing process. Certainly pollution prevention, pollution control, and pollution practices, not only from the societal norms, which we expect our businesses not to do any harm to the environment, but also there's a lot of local, state, and federal regulations that's going to regulate businesses in doing that. Certainly how they go about recycling their products, their inputs, and their remanufacturing. And in some companies, really are about using recyclable products to make new products. So environmental certainly is something that every business has got to be concerned with. Then over on page number 81, we talk about cross-functional cross-functional decision making, which is something you've already been exposed to over in chapter 2. And in this particular page, it really focuses on marketing and the operations interactions when it comes from marketing and the financial piece of that as well, coupled with human resources information systems. So it is important from a cross-functional decision-making, cross-functional teams, which we saw back in chapter 2, how important it is and how those decision makings need to be made at all levels within the organizations as we go about determining the future capabilities of that particular organization and how that organization is going to respond to the competitive environment that they find themselves in. So that concludes chapter 4. Let's get into the last chapter for this week, and this goes into service delivery and system design. And on page number 87, the operations leader looking at Montgomery School, public schools, again, is to me a very interesting example of a real world application of this particular chapter. So let's look at defining service, if we could, over on page number 88, where we're looking at service is typically the intangible or tangible. And in this particular example, let's focus on service stresses the intangible of its offerings and services. They create value for customers by performing the transformation that do not result in the physical entity or product. So a service is about intangible offering that creates value for the customer that by performing some transformation. In other words, you're satisfying my intrinsic need as you provide me customer service in the way I'm treated, the way I'm viewed, the way I'm communicated with, and I'm not having my hands on a tangible product per se, but the way you treat me, the way you communicate, the way you help me solve my problems is part of this intangible service that this particular chapter starts out with. And It's important to consider the characteristics of such processes and their implication for both managers and customers. So because we're a customer-oriented society, a business that does not have good customer service, after the sale customer service, helping customers solve their problems, may find that they're not going to be competitive as they wish to be. Continuing on page number 8, simultaneous production and consumption is another critical characteristic of services because it implies that the customer may be in the production system while the production is taking place. This is where that house of quality we talked about earlier in the previous chapter, where you're trying to satisfy the customer because you're listening to what that customer's needs and desires, wants. And in a customer service organization, you're really having high contact time with that customer, and it's really about providing those services that meet that customer's needs. In this high contact example on page number 88, they give us the example of tax and accounting services, retail services, automobile and appliance repair service, and even governmental services as well. And it's important to distinguish between the service processes that are typically called front office and those that are in the back office. Processes that require the presence of an interaction with the customer or high contact with the customer is typically considered the front office service processes, where the back services does not require the presence of the customer. So high contact front, low contact is back in the back office concept. For example, bank tellers, dentists provide front office services as they're interacting directly with the customer, as would be an example. Yet, from the back services, in contrast, could be I'm processing your check, or could be that I am doing your x-ray development, would be the difference between front office, which has high customer contact, and back office, which has minimal to no customer contact. And you kind of see that contrast between products and services shown over on table 5.1 on page number 89. So understanding the difference between back and front office is good, useful information. Now let's look at page number 89 as we talk about service product bundle. We love bundle. It's one of those concepts that if I can, and I'll use this as an example, technology when it comes to buying your cell phone, or excuse me, get your cell phone service, your internet service, and your cable service. If you get it all from one provider, they typically offer a bundle package, which is typically a little bit lower in cost because you're bundling all those services. Well, in a service product bundle, we're looking at the tangible, the intangible, and the physical goods as a service product bundle, which consists of those three elements. So most service come bundled with tangible services, intangible service, and facilitating goods. And you kind of see that figure 5.1 on page number 90 as it kind of distinguishes, gives us a comparison of the percentages of various products and or services. Then let's talk about customer delivery system matrix, where we have this matrix on figure 5.2, which is looking at the dimensions of what the customer wants and needs and what the customer is seeking compared to the service delivery system. And again, this reads from left to right, top to bottom. If we're looking at, as an example, with a limited number of process pathways, line flows, low work complexity, compared to a standardized with highly repeatable process sequence, customer has low decision-making power. That would be an example of a provider routed ATM. Limited, absolutely no contact with a customer service relationship banker. Walk up, use your card, everything is self-service, absolutely no interaction, very standardized process. It is what it is, and that's an example of a service delivery system compared to a customer like estate planning when I'm sitting down across my lawyer. Highly customized, a lot of process pathways, a lot of personal contact, front office type delivery system. So they kind of give us those different matrices and examples on page number 91, 92, as well as 93 when it goes into provider routed services that has few options during the delivery that are matching the customers what they need. ATMs, which is another example of self-services, which is also considered a delivery design system where you see that person standing at the ATM machine. Over on page number 94, we get into this concept called customer contact. And it just gives you, again, a figure 5.3, where we're looking at the worker requirements and the varying levels of skills, what is needed, and the degree to which customers are being serviced or contacted. And you can see the difference between those. As we all talked about, high contact services involves the customer during the production of services, because high contact front office, an example we already indicated would be the dentistry, the banking. The other examples would be someone who's getting their hair fixed, or sitting down, doing estate planning, or doing estate planning, or sitting down with high one-on-one customer contact, like doing a consulting process. Now, as you can imagine, from a production standpoint, high contact typically is inefficient, and it's inefficient from the standpoint, if I'm trying to do a volume business, the more time I spend with the individual customer, the less time I can spend, or the less number of customers I can see per day. Some businesses operate that way. Some businesses demands high customer contact, but it is a way of which we measure inefficiency, as you see it at page number 95 with that formula. Potential inefficiency equals the function of the degree of the customer contact. I know I have been in some offices where it was almost like an assembly line. They wanted to get you in, address your concerns, and get you out as quick as possible, because they've got people behind you waiting to be served. So that potential inefficiency. The more people I can see, the volume increases, the potential more profit that I can make. And operations managers in the middle of page number 95 must be concerned with the amount of customer contact, because higher levels of customer contact can introduce variability in the process. And that variability is a challenge for operations managers, because it takes capacity planning, which is more difficult and can result in long waiting lines. And because of this variability when it comes to service delivery, there's certainly uncertainty introduced by the customers and what they need, what they think their problems are, and how you can go about solving those problems. And they're categorized as customer-induced variability based on the various types of uncertainty. And table 5.2 back over on the bottom of page number 95 gives us some examples of the different types of uncertainty: arrival variability, request variability, capability variability, effort variability, and the subject preference variability. So the potential inefficiency is a function of the degrees of customer contact. And the higher the levels of contact is a costly in terms of lost efficiency. But yet, there's a potential opportunity to increase sales to customers through word of mouth advertising, which has the potential to increase additional revenue. And if I think about it from this standpoint, let's say that I take my automobile in to get a repair, and I think it's going to be this. The auto mechanic looks at it, diagnoses it, and gives me an estimate. But then when they actually get the vehicle up on the lift, they identify another problem. Now we're at a decision point where the variability is going to increase. So now we thought it was going to be this defined amount of time making this repair. Now that time has been expanded. And when that time gets expanded, I got the car up on the lift. I have got the mechanic or the automobile technician who is working on that particular automobile, which now we can't move on to the next one as a auto dealership. So that's an example of this customer-induced variability and the potential inefficiency when it comes to the high contact of customer dealing with their problems. And we see that further example are the characteristics of high contact and low contact services over on page number 96. Then we go into service recovery on the bottom of page 96, 97, which is another important element that is looking at service failure when something goes wrong during delivery of the service and how we're going to recover from that by offering service guarantees. We love guarantees, and it's a way to define that the service is satisfactorily delivered to the customer. Operations leader at the bottom of page number 97 is a great read to give you an example of this thing called service guarantees, and I think they're talking about the UPS, it's UPS service recovery, when they're looking at making sure they go above and beyond what the customer's wants and needs are as part of that service guarantee. Amazon, and I keep coming back to Amazon. Amazon really has got this customer service concept really nailed down when it comes to ensuring that the customer is satisfied. I know from a personal example, I ordered a product from Amazon. My product got delivered to an incorrect address. Their database indicated that it had got delivered and that it was located in this section, in my example, on my back porch. I called Amazon and told them I did not have a back porch, did not have my product. There was no debate, no question. They immediately refilled my order, and they told me that if the other order shows up, just send it back. And they gave me the address and the cost codes where it didn't cost me anything to send it back. And about 2 weeks later, the other order finally arrived, and it came up to be the shipper issue, not Amazon, but that to me is that service guarantee that Amazon stand behind to make sure the customer gets satisfied. So that's just my personal example of a service guarantee and the impact that it influenced me when it comes to the service guarantee and doing business with a particular entity. Now, let's talk about globalization of services over on page 99 through 101, when we go into how this production line approach to service, which is good when it comes to standardized cost, when it's designed to minimize mistakes. And we go into this concept over on page 101 of outsourcing and offshoring. A little bit of difference in their activities, where outsourcing is a organization that's going to outsource some of the what I would consider to be non-critical activities. That if something were to happen to those activities, it would not have a negative impact to the company. Some of those, not that they're not important, but they're not mission critical, that if I didn't do it today, I would not be losing my proprietary information or some sensitive technological piece that really defines the company, typically more an administration type of activities. Again, not that they're not important, because they are, but it is a way for a company to look at lowering costs. And certainly, if your company deals with a call center, then more than not, that's a offshore activity. But outsourcing services is a way in which a firm can perform some of these service activities, such as recruiting, payroll management, accounting services, and call center functions, where I outsource those outside of my company. They may still be here in the United States. Typically they are, but I am still have some manner of control, because I've outsourced those activities to a third party company here within the United States. Where in contrast to offshoring is that I've completely exported those service activities to another country. So the key here, offshoring, is I may use some of those same activities, but I actually export those to a different country. They're not onshore with me, they're offshore. We're outsourcing. They may be onshore or offshore, but typically more onshore. Typically, not true in all cases, but try to give you an example. And at the bottom of page 101, they kind of give us these 5 major findings when it comes to the reason why companies are offshoring some of its activity. So again, outsourcing is a function where I'm outsourcing those to a third party. Offshoring, where I'm taking those activities and I'm exporting those to a third party in another country, not even within the bounds of the United States. A little bit of difference between offshoring and outsourcing. Then we look at page 102, offshoring services to India. The operations leader is another good example. Then let's look at employees and services on page 102, 103, when we look at the service profit chain and how service profitability is linked to focus on customers and employees, which is of paramount importance. And as we look at figure 5.4, the links in the service profit chain, we see that employee satisfaction, customer loyalty, internal service quality, all those attributes are part of the operating strategy of a surface profit delivery, surface profit chain system. And you see that again over on page 102 and 101. And they follow up that discussion on page 104 when they talk about productive employees, employee retention, which certainly is a strategy that all companies need to be looking at very strong today, because there is a cost associated with to a company when employees, we have high turnover of employees, and we have satisfied employees and eternal service qualities. So that is the major points that I wanted to discuss in chapters 3, 4, and 5. Hopefully, this will be of some value to you. Be interested to get your feedback in doing this, to see if we need to continue for the subsequent chapters coming up. And with that, thank you so much for watching, and have a great day.